Hello, everybody, and welcome to episode 91 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. Over there is Gavin and Fia. And fellas, I'm just glad to be back.
We are glad to have you back.
Yeah, absolutely. So for
Thank you,
anyone
guys.
anyone not aware, Mike has been out in the wilderness, living off of the land in the Adirondack Mountains.
I would not
And
call
so
either one of those things true, but, we'll go with it.
So Mike, so you were hiking the Adirondack high peaks, and there are 46 of them. That was your goal for the
Right.
summer. What did you end up getting to?
So I wound up at 35 high peaks, and
Wow.
Yeah, that's
I
awesome.
I think I would have been able to finish. My problem is that I wound up booking myself solid for like the last week and a half of summer. So I wasn't able to get up there. However, and this is the first time you guys are hearing about this, so live on the podcast here. So the original goal, summer was 69 days long, and I wanted to do all 46 high peaks in 69 nice days.
Right.
However, do you guys know what the second funniest number is?
No.
420.
420. 420 days falls next August. So the plan's going to be that I finish my 46 high peaks on day 420 because, and this is true, I'm a literal child.
Nice.
I love it.
Yes,
That's
nice
awesome.
indeed. So yes, but thank you guys very much. It was a really fun summer getting a chance to do all of that. If you ever get a shot, if you're in reasonable shape, anyone can do quite a lot of those high peaks. There's some that are reasonably challenging, but I have very little mountain climbing experience, and I was able to pull it off. So if you get a shot, if it's something you want to do, I highly recommend it.
Awesome. Yeah, and spoilers for a potential future episode. We may or may not have an episode all about the Adirondack Mountains lined up. It's not next episode, I'll tell you that. We've also now been in the habit of mentioning our next episode topic, the episode before, so that if listeners have questions or things that they are curious about for the topic, they can feel free to, ask us on Twitter or Facebook or YouTube in the video version of the podcast. So next week we're talking about volcanoes, which is an interesting one.
Big fan of volcanoes.
So for all the paleontology talk on the podcast, I'm also a geologist, and that's actually the bulk of what I actually do day to day at this current job is geology. So so I'm excited for next week. But Fia, tell the people where they can find us.
Don't forget to rate the show on whatever platform you listen to, and to follow us on Twitter, Facebook, and YouTube. And, like Gavin said, give us feedback and talk about any future topics you would like to hear on the pod. If you want to be a guest on the show, be sure to fill out our guest form, which can be found in the show notes.
Awesome. And for the first time in many a week, we have a Today in History.
Yes, so Today in History, we are going to have some classic Mike Bryson Today in History. So in 1990, I will ask you guys this, and I know neither one of you are huge baseball fans. Are either one of you familiar with a famous person who played baseball who was a junior?
No.
Junior as in?
Like their name and then junior.
Oh. No, honestly. I'm only drawing basketball names. That's all I got.
So are any of you guys familiar with Ken Griffey?
Okay, yeah.
Yeah, so Ken Griffey Jr., famous baseball player, one of the greatest of all time. His father also played baseball.
Right.
And very briefly in 1990, they played together. And in 1990...
That's cool.
What's even cooler is that in 1990, today, September 14th, 1990, they hit back-to-back home runs in the first inning.
Aww.
So they were hitting back-to-back in the lineup. They each hit a home run in the first inning. And as far as baseball history goes, yeah, it's one of the coolest things that's ever happened. It gets shown on highlight reels. It's just kind of a cool moment. Again, a father-son combo, getting a chance to do that. So that's our Today in History. Not exactly monumental.
What team?
The Seattle Mariners.
Okay.
So they were playing for, and that's who Ken Griffey Jr. is kind of most well known for. Ken Griffey Jr. Sr. is not the baseball player his son was, but still he was hanging around long enough for his son to make it to the big leagues.
I definitely would have gotten emotional if I had saw that in person.
Absolutely. I mean, it's awesome. It is, if you ever get a chance to watch it, there's clips on YouTube. It's just a cool moment if you're ever looking for something to give you a smile.
Yeah. So I also, a little behind the scenes things here. So I asked Mike if he could try to find a Today in History that had to do with
I wasn't going to bring this up.
the George W. Bush administration, because coincidentally, currently as we are recording this, Condoleezza Rice is speaking to my university.
Oh, really?
Yeah. My university is doing a series this entire academic year on democracy, and
Well,
she was the first one that is speaking on the docket. Other speakers include people like Jake Tapper, David Axelrod, John Kasich as well. So neat lineup. I probably would have gone if it wasn't, podcast day, but I'm like, I don't care enough to move the podcast. Condoleezza Rice, out of all of them, is probably the one that I want to see least.
Yeah.
So
County Rice, for those of you that don't remember, was National Security Advisor and then Secretary of State in the Bush administration, the second Bush administration.
Yes. So, and it was also over Zoom. So it's like, it's not,
never mind.
Exactly. So, that's why I was like, we're doing normal podcast day. But yeah, so that's why I had asked Mike to do that. But with that out of the way, Fia, what do you have for us for Swamp Corner?
Thank you, Gavin. I have decided I would like to implement a new thing for Swamp Corner, and that is to tell a nature dad joke, because I love nature and I love dad jokes. So I will ask you a question. What did the blue whale say to the orca?
I don't know.
Do I start making Dory noises? I got nothing.
Don't krill my vibe.
Oh.
If you don't get
That's
it,
rough.
No, I get it. Fia that.
Well, for the listeners,
if you don't get it, blue whale eat krill, and blue whales and orcas are kind of enemies. So
that's true, and both coincidentally live in and around Antarctica, which is the topic of the episode.
That's a hell of a transition right there.
Well,
you guys got real good while I was gone.
Swamp Corner. We have the rest of Swamp Corner.
Sorry.
Way to go, Fia.
I also took the time to make my Swamp Corner snippet also about a little bit around Antarctica. And I wanted to talk quickly about an amphipod that was recently discovered and recently I mean 2017.
Okay.
Amphipods are very small type of crustacean that are found pretty much everywhere geographically. I couldn't find a place that they didn't live. And they can also live in fresh, brackish, salt water, and even on very moist land. The specific amphipod that I wanted to talk about is Epimeria cinderella, which I think is a really cool name. Yeah. Most of the 28 new species that were found in Antarctica during this time, this was one of them. They have large spikes protruding their back, and they're really like extravagant. But this species was named Cinderella for being kind of humble looking. Like Cinderella was kind of a humble princess working for her stepmom. Mm-hmm. And so, yeah, this was found in Antarctica on Elephant Island, which I guess is part of Antarctica. Yeah, it was pretty cool.
Nice.
Elephant Island, you said?
Elephant Island.
A lot of the islands around Antarctica have names that don't belong.
Yeah.
Is there a reason for that?
No. Nope.
Just because
elephants or their relatives definitely never got to Antarctica or any of the islands. So, no.
Noted.
But
yes, so take it away,
smooth transition to the main topic of the episode, which is the continent of Antarctica. And so I guess for both of you, what is the first thing you think of when you think of Antarctica?
So I unfortunately thought Antarctica was in the north until last week.
Okay,
right, I realize I'm wrong.
Yeah. We'll talk about that. That is actually an interesting thing. We will talk about that.
I mean, Fia, I teach social studies here. This is, Fia.
I don't. Everybody has their moments.
That's fair. This is a
So,
no judgment zone on this podcast.
all right. So when I think about, did you say Antarctica or the South Pole?
Either or.
Okay, so when I think, I guess this applies to both. When I was in ninth grade, I had to read a book in English class called Ultra Marathon Man, and
Okay.
where this dude just liked to run a whole bunch. And at one point, he was in Antarctica, and he got to the South Pole, and he and his buddy were like, "You know, it'd be really funny if we took off all of our clothes except our boots and ran around the South Pole, like just like in a very small circle right around the South Pole, and then we
Sure.
could say we ran around the Earth naked." And there was a picture
my
included
God.
in this book with all the giblets covered up,
Sure.
and it's a very funny picture. And so when I think of the South Pole for the rest of my life, I have always thought of my freshman year English class and this picture of a very well built man, completely naked, in the middle of the South Pole.
Oh, geez.
I'm not really sure what you were thinking when you were asking that question, but damn it,
Not that.
damn it. Welcome back, everybody. Mike is back on the podcast. You get what you get.
So, most people would think of Antarctica as just this land of ice, basically the North Pole, but opposite. And that is in some ways true, but a lot of ways is not true.
Can I guess one of the ways that this isn't true?
Sure.
So Antarctica, my understanding is that in addition to all of the ice on top, there is like actual what we would normally consider like land, like a continent on the bottom there, kind of anchoring it all in place. Whereas I don't know how much actual land is up in the Arctic. It's just kind of like floating ice. Do I have any part of that correct?
Absolutely. That is almost entirely correct.
Oh, hell yeah. I'm back. We're in business. Here we go, Gavin. Give me the science
So-
crap.
So, Antarctica, while it's a very unique continent for reasons that we'll get into, just like North America, Europe, Asia, etc., it is just a continent. It has lakes and rivers and volcanoes and mountains, like every other continent. But it is 97% covered in ice that is sometimes miles thick. And that makes everything else around it, or about the continent, a little less interesting. And most people also think of Antarctica as just this giant landmass, because anytime you look at a map, it is portrayed as being giant. It takes up the entire bottom 25% of a map, depending on what kind of map you're looking at. And that's mostly just because that's of how we make maps. It's very hard to take a thing that is round and make it flat and make it everything still look the same size and shape.
Yeah.
As it turns out, it's impossible.
Yes, you cannot do that. So in order to take a globe and make it flat into a map, you need to take some creative liberties. And usually what happens is the simplest way to do it is to stretch out things at the top and bottom, because those are the things that are the least relevant to most people. So it makes the closer to the center of the map you get, the more normal things look relative to each other. But then when you get toward the top or bottom, things get stretched out and appear much bigger than they actually are. That's why Greenland always looks so big. And Greenland's big, but it's not nearly as big as most people think it is.
Right.
And the same thing is also true with Antarctica. And so Antarctica is the 5th largest continent out of the 7. Yeah. So the only ones smaller than it are Europe, which barely counts as a continent. It's just sort of a nub off of Asia.
Right.
And Australia. Australia is also much smaller than you think it is, but a similar thing is Antarctica, because it's so far south it usually gets portrayed as bigger than it is. So it's not much bigger than Australia, but it is bigger. However, Antarctica also does appear a little bigger because much of that ice on the continent also extends out into the sea. So the actual profile of Antarctica appears even, quite a bit bigger than the continent actually is as well. So some more just quick tidbits about Antarctica's ice. Like I said, over 97% covered in glaciers, which, for anyone not aware of what a glacier really is essentially a massive river made out of ice. It flows like a river, much, much slower than a river does, but it moves and flows very much like liquid water does, except it's solid and miles thick. And just to sort of wrap your head around a little bit how much ice this is, 70%-ish of all fresh water in the world is in Antarctica's glaciers.
Wow.
Yeah,
70?
70.
Oh boy.
And also, if all the glaciers melted, that would raise sea levels by roughly 200 feet.
Oh, I would be in so much water right now.
For reference, about a third of people on the planet live below 200 feet in elevation.
Yeah.
So that is an enormous amount of water.
Yeah, it is.
Antarctica also is just generally on top of the ice is just a general land of kind of extremes. Antarctica is on average the tallest continent, even including places like Asia, which has the tallest mountains in the Himalayas, or South America, which has the second tallest mountains in the Andes. On average, Antarctica is the tallest continent. Most of Antarctica is very high elevation.
I have a question.
Yeah.
Is the height including the ice formation, or is it
No,
just talking about the actual land?
just the bedrock.
Wow, okay.
Yeah.
That's surprising.
Antarctica is very tall. It also has the coldest temperatures on the planet, which probably isn't all that surprising. The coldest temperature, natural temperatures anyway, is negative 128.6 degrees Fahrenheit.
Is there a reason why the South Pole and Antarctica is colder than the Arctic?
We'll get there.
Okay.
Yep. Spoilers. So there are reasons for it, but we'll cross that bridge when we come to it. And for all of our non-American listeners, that is negative 89.2 degrees Celsius. And, oh, just kidding, it's literally the next bullet in my notes. Part of the reason that it's so cold is A, the darkness, which the North Pole also shares, in that for about 4 months of the year, not a full 6 months, but for about 3 to 4 months of the year, it is complete darkness. The sun does not rise.
Wow.
Yeah. And that's just because of the way the Earth is tilted.
Mhm.
During their winter, which is the Northern Hemisphere's summer, the sun just does not rise. So obviously that makes it much colder. But the North Pole also has that. What sort of sets Antarctica apart is something called the Circumantarctic Current. There is an ocean current that just flows in a big circle all the way around Antarctica. It doesn't flow anywhere else. There are some currents that do leave Antarctica to go to other places, but the North Pole, because it is not a landmass, there is not a current of water that helps isolate it from other ocean currents.
Hmm.
So because of that, it just makes a big ring that sort of encloses Antarctica from getting any outside heat that it might otherwise get.
I'm assuming that's unique compared to other continents or land masses of any size. Is just having kind of its own current that just encircles it.
Yes. And if you think about it, the only other continent that could do that would be Australia.
Right.
Because all of the other continents are fairly close to one another, or at least to another continent. And it also helps that Antarctica is relatively small, because if there was a current that was running around North America, even if there was enough space between North and South America, that would just need to be a gigantic current. That would be just naturally, that'd be a lot harder to form, let alone a current that ran around just Eurasia. That would also have to be enormous. So yeah, a lot of factors go into Antarctica being extra cold that just the North Pole just doesn't have. And also something else that makes Antarctica kind of unique is it actually has a very large degree of international cooperation.
This is one thing I am aware of, yes.
So around 30 governments around the world govern Australia. I'm going to keep saying Australia. I mean Antarctica. And there's a reason why I keep saying Australia that I'll come back to. Yeah, around 30 governments share the governing of Antarctica and have agreed that no military activity, no mining, no nuclear testing, or no nuclear waste disposal can be done there. And that's been the case since I think 1953 is when that treaty was signed. And that's basically they were pretty much like, well, we can't have people live here. We can't make, major cities and settlements here. So we can't exploit it really. So we'll just use it for science.
Darn.
Back when people funded science. Yeah. So, a fun anecdote about its name and why I keep calling it Australia. So, the word Arctic comes from ancient Greek meaning northern and also can mean of the bear. Because to the ancient Greeks, bears lived up north.
But
Antarctic.
this is not in the north.
No. Antarctic comes from, ant meaning opposite, like, anti, and Arctic. So, anti-Arctic. So the name literally means where there are no bears. Or also, if you're lame, to the south. Historically, a lot of early European philosophers, even all the way back to ancient Greece, sort of figured that, well, there's all this land in the north, there must be land in the south to balance the world. Otherwise, we'd all just fly off of it. Because they didn't know how planets worked.
Nice.
They accidentally ended up being wrong, or accidentally ended up being right. And even Aristotle, way back in 350 BC, thought that there needed to be land down there and called it, quote, an Antarctic region. And later on, most European philosophers would call this hypothesized land in the south Terra Australis, which just means the southern land. When the Europeans, quote-unquote, discovered Australia, even though there were people there, they basically thought Australia is as south as it gets. There couldn't possibly be another continent more south than this. So they named Australia after this Terra Australis. And then sometime later, we discovered Antarctica. And I say actually discovered Antarctica because it is the unique also, and that is the only continent without native peoples.
I have a question on that. So,
go for it.
Talking like we've mentioned before about these supercontinents and semi-supercontinents in the past.
Yes.
I believe I'm correct in saying that all of those well predate humans in any like reasonable form.
Very far.
Okay. However, because Antarctica actually has like land on there and was part of this, several supercontinents, was there more typical life on the Antarctic continent, going back thousands or millions of years that we wouldn't now associate with Antarctica being the barren, cold, wilderness that it is?
Absolutely, and we will definitely get there.
Okay.
But that's more spoilers.
All right, I'm looking forward to it. Here we go.
So, since we're talking about the history of people on Antarctica, that has a really long, really interesting history, but TLDR, the first people saw it or claimed to have actually seen it in 1820, which is probably more recent than you might have been thinking. And hypothetically, there might have been some Pacific Islander or South American sailors that might have seen it and then promptly died because it was way too cold for them. This is one time where I actually kind of give credit to the people who said they discovered a landmass.
Do we have the names of these people that first discovered Antarctica?
I do, but like I said, that's a very long history. It's really interesting, and several, depending on which account you go by, it was either a Russian, a Brit, or an American, and they all claimed to have seen it within the span of 3 days. Each of them claimed to have seen it. So yes, independently. So who actually ended up seeing it first? It's kind of unclear. Really interesting history that we don't have time to get into. So I will leave some links if you want to find out more, some links down in the show notes about it.
Cool.
But since 1953, there has been a year-round population of about 1,000 people. And during Antarctica's summer months, which are the northern hemisphere winter, it bumps up to about 5,000 people, primarily scientists, engineers, people doing experiments. Because it's a really good place to do various scientific experiments because it's away from people. So it's a really good place to study space because there's no light pollution. It's a good place to study atmosphere and climate stuff because there is still some, but there is less pollution. And obviously, modern climate change because of what we're doing to us, Antarctica. That's also kind of a thing in the news right now because there's a giant glacier that is, from what I've heard, give or take the size of Florida, that is about to break off from Antarctica.
Oh,
That by
wow.
itself could raise sea levels uh, a few feet if it all melted. So, not great.
Yeah, not
Yeah, that seems
great.
problematic.
Yeah, especially for Florida. That seems like a place that could not stand for sea levels to go up a couple feet.
Louisiana also.
Louisiana as well. That is correct. So, with that, we're going to start talking about some of the life that lives there, which is arguably something that Antarctica is just as famous for as all the ice. And with it being covered in 97% ice, life's pretty hard to come by. And while it's famous for one particular group of animals, there's more diversity there than you might think. Those particular animals that it is most famous for are obviously the penguins. Everybody knows, everybody's seen Happy Feet, you know?
Oh, yeah.
Everybody knows at least what Happy Feet is. So there are quite a few species of penguin that live on or on the islands of Antarctica, but the main one that lives on the actual mainland Antarctica is the emperor penguin. Really big, the biggest living penguin. And they're also unique in that they're the only Antarctic animal to breed there during the winter. So they lay their eggs in like peak darkness, which is interesting. Like I said, even including all of the various insects and things that live there, the only ones that breed in the winter.
When you say breed, like, what are we talking here?
So they're birds. So they will mate and then lay an egg not terribly long afterward. And then the
Does
males
that
are
all
typically
happen
the
in the winter?
ones. Yeah,
Okay.
the males will typically be the one to hang out with the egg. They keep it between their feet, and when they need to walk, they'll just sort of waddle with the egg between their feet.
Mm-hmm.
And sometimes the female will be gone for weeks eating food and stuff, and then she'll come back and they'll switch off and etc. And so I don't know exactly how long it takes an emperor penguin to hatch and then mature. I know I see lots of footage of them still being all fluffy and babies with it being light out, so I don't think it takes terribly long. Yeah, breeding in a time of like limited resource availability is very strange.
Yeah. But I guess an advantage of that would be that the baby hatches during a more advantageous time of the year.
That's true. I didn't particularly see a reason why, but yeah, that makes sense.
Yeah.
There are also lots of other birds that live there, and most of them fly and don't live there year round, and some even make the trip all the way from the actual Arctic and just spend the northern hemisphere summers in the Arctic where it's sunny all year, 24 hours a day, and then fly down for the southern hemisphere summer where it's also 24 hours of light. So they basically just bounce back and forth for each place for a couple months while it's light out. A number of whales also make that migration. Mostly things like blue whales, other large baleen whales. There are also a resident population of orcas that stay there pretty much year round.
Well,
The orcas mostly eat things like the penguins, and also there's a very large number of pinnipeds, which are your seals and sea lions, that live there too, that the orcas eat. And even lots of things like your leopard seals, which are very famous. They're very fun. If you ever see like videos of like a big seal or sea lion coming up and exploring a diver, it's probably a leopard seal. But there's also crab eater seals, Weddell seals. However, those and the whales are pretty much the only mammals. There are no mammals that really come up onto land all that much. Just the birds.
Okay.
And pretty much just the whales and the pinnipeds and stuff are pretty much the only thing I'm going to say about the oceans around Antarctica. I'm doing them a great disservice because
yeah.
Arctic and Antarctic waters are incredibly nutrient rich and very diverse. And if I were to talk all about them, we'd be here all day. Unfortunately, they're going to have to get skipped. Sadly, I'm sorry, Fia.
It's okay. I learned through my swamp corner, at least 28 amphipod species live there.
Cool. But yeah, and so just a quick note on why the waters are so much, more nutrient rich. There's a lot of, it's called upwelling. So because the waters are fairly cold, um, they sink. And if something sinks, there needs to be something to move up to take its place, so it's not just like leaving a vacuum of empty space. And so water down around the bottom of the ocean tends to be fairly nutrient rich because all the dead stuff is, dying and falling. And so all these nutrients dissolved in the water get flushed up toward the surface. And so because of that, that's why there's all those krill that Fiat mentioned at the beginning that things like blue whales and other large baleen whales eat. So even though there's not sunlight every day consistently, there's still extremely diverse, very productive marine ecosystems around there.
Nice.
Yeah, so moving on to the fully terrestrial things, because the penguins, are semi-terrestrial. They're obviously much more clumsy on land than they are in the water. But there are a number of things that are fully terrestrial in Antarctica, starting with over 100 species of moss.
What?
Moss?
Yeah,
But
moss.
darkness.
Yeah. So I'm sure a lot of them. I couldn't find a good list that just included mainland Antarctica. A lot of them still included the islands outside, which technically counts, but in my book is still a little cheating. So there are 100 species of moss-ish, and 2 species of flowering plants. One that looks very much like a moss, and one that is a grass. So plant diversity is more than you'd think, but still not high,
Right.
considering how diverse and crazy plants are. Much more diverse, and even more crazy, in my opinion, are fungus. There are 1,150 known species of fungus known from Antarctica. However, most of them are microscopic, and most of those that are not are lichens.
Are what?
Lichen?
Which is?
Ooh, fun. So lichen, if you've ever seen like a crusty thing on a rock, that's probably a lichen. So lichen are, depending on how you categorize it, some form of symbiotic life form between fungus and algae. So the algae does photosynthesis, and the fungi break down the rock or tree bark or whatever they happen to be on and give the algae nutrients in exchange for some of the food that it makes with photosynthesis. So if you've ever seen like a splotch of like pale green color or like orange color just on a rock for no reason, that's a lichen. Yep.
Okay.
They are extremely hardy organisms. They are some of the first organisms to make it into an environment. So, for example, if like a new island pops up somewhere in the Pacific, like a volcanic island, lichen will be the first things there because they can break down the actual rock into food.
How do they get there in the first place?
So I guess in this case they'd be like have spores on like the feet of birds or something that might stop there. So I guess the birds would be the first ones there, but lichens would be the first ones to like live
to stay there. Yep.
Yeah.
Okay.
And it's even thought that a lot of the lichens and fungus were probably brought to Antarctica from birds because a lot of them are very similar and in some cases the same as the ones found up in the Arctic. Yeah. And in and among all these plant-like things are quite a lot of terrestrial invertebrates, namely nematodes, which are very small, superficially worm-looking things. In most cases, microscopic or otherwise very small, even if you can see them with your eyes. They're very abundant, and in some of the most remote areas, the animal food webs consist only of 2 herbivorous nematodes and 1 predatory nematode.
Okay.
Nice.
Yep.
That would be a very nice system to study.
Yeah. I'm sure it'd be very interesting.
Yeah.
And on all the main outlying islands, you could find various species of spiders and different kinds of insects. But on the actual mainland, there's only 1 species of insect found, which was the most surprising thing that I'd heard out of all of this, because insects are crazy. And the only insect is a species of wingless midge, which is a type of fly, that is about 1/10 of an inch big, which makes it the mainland's largest fully terrestrial animal.
That's funny.
Yeah. So, very extreme place. So, like I said, getting back to what Mike had asked about, like some of these organisms, like those fungus and some of the lichens, were probably brought to Antarctica from the Arctic, but a lot of them, like some of the insects, and especially things like the penguins, which can't fly, uh, probably evolved from animals that were on Antarctica to begin with, because Antarctica was not always this desolate wasteland that we know it as today. So, what was Antarctica's past like?
Dark.
Not always.
I mean, I would imagine it was just like a regular landmass when it was part of, Pangea or, the other supercontinents if it was further north.
Yeah, for the most part, that's pretty much the case. So, even though
Okay.
it existed before this, we're gonna start at around 550 million years ago. So the actual continent was doing its continental drift thing before this and existed, but it's sort of best started around here because around this time is when the smaller, lesser known supercontinent called Gondwana came together. So
Gondwana.
Gondwana is one that we've talked about quite a bit before on the show, but it is the
Hmm.
supercontinent of what are today all of these southern continents. So it was South America, Africa, Australia, Antarctica. Well, now India is in the north, but back in the day, it was part of Gondwana as well as smaller places like Madagascar, New Guinea, places like this. So they were all smushed together in a supercontinent way before Pangea. So this was 550 million years ago, is when all these started to, join together. And the two that are the most important to Antarctica are South America and Australia, because they hung around with Antarctica the longest. We'll get there when we get there.
Hmm.
And the reason why Gondwana is so important to the story of Antarctica is because this supercontinent would last for 330 million years. It survived the forming of Pangea and the breakup of Pangea. All these continents stayed together during all of that.
Love that for them.
Yeah.
Jeez.
So if you look at even today, a lot of you can find it best today in the plants. Plants in South America are very similar to plants in Africa, very similar to plants in like New Guinea, because that was also part of Gondwana. And that's because when they evolved, they spread just all across this giant continent without really getting up to the northern continents because they weren't connected.
Hmm.
And it's very helpful that all of these continents were connected to Antarctica because we actually have access to very little material from Antarctica itself. Any particular guesses why?
It's very cold.
That's the only obvious answer. I got
Yeah.
nothing. Yeah. Okay.
So this is a perfect example of sampling bias in paleontology. Because it is such an inhospitable environment, you've got maybe 3 months tops per year, and it's also extremely expensive to go there and stay there and do anything there, because to go anywhere you have to fly. There is no way to drive from place to place really outside of the small settlements there. So if you want to go anywhere, you have to fly, which is really expensive. And also, it's just a horrible environment. So because of that, we do have some fossils, but not nearly as many as even places that have been historically underexplored, like Africa and like South America. We're going to be relying a little bit on some of Antarctica's former neighbors for some of this story. Yeah, we know most of Antarctica's story, but that's one of the plus sides of global warming is we'll get through that ice eventually.
Gavin
And when we
Davidson,
do, there'll be some
global
great
warming.
fossils.
Oh.
Yeah, sad, but silver linings, I guess. For most of Earth's
Sure.
history, Antarctica was actually, like Mike said, fairly mild in climate, kind of like North America is today. During the first chunk of that time, which is the Paleozoic era, which we've talked about quite a bit, all of the episodes that we've done about geologic periods so far have been in the Paleozoic era. It was the first, from roughly 550 to about 250. million years. And
Cool.
so around this time, Antarctica was around the equator. There were parts of it that even got a little above the equator. But Gondwana was very slowly just all the continents drifting south. And during this time, we pretty much only have marine fossils known from Antarctica. So we have some land plants, but no land animals, really. And this is also sort of leads us into how we make some inferences about places like Antarctica when we don't have a full set of data. Because throughout this entire time, we have no tetrapods known from Antarctica. Tetrapods being land vertebrates. So we don't have any reptiles. We don't have any mammal ancestors. We don't have any amphibians. We have none of it. We can be virtually positive that they were there because we have them from South America, which was on, say the left side of Antarctica. And we have them from Australia, which was on the right side of Antarctica. So presumably they were also in the middle in Antarctica, but we don't have the fossils from there. So it's kind of hard to say.
Yeah.
But like I said, we do have some marine fossils, and they were pretty typical of this time period. They're very similar to everywhere else. Nothing crazy exotic yet. Some trilobites, some brachiopods, crinoids, and such.
Sorry, how does one collect marine fossils?
So over time, rocks will get uplifted, so they are no
Okay.
longer in the ocean.
I wasn't
Just
sure.
through a lot of general geologic processes, mostly continents slamming into each other and, causing mountains to be built, more or less.
Okay. So people aren't actively sending machines down to the bottom of the ocean and taking rocks.
Not for these kinds of fossils, no.
Okay.
There are some fossils that can be found like that, but that's very expensive to do. And most of what you find are single-celled things, which are really good for paleoclimate studies because they have interesting isotopes that can be used to measure various things. You can listen to episode a couple episodes ago. Let me look. Episode 87 about paleoclimate with my coworker, Dr. Lorelei Curtin, and she'll tell you all about it.
Cool.
But anywho, toward the end of the Paleozoic, in the Carboniferous period, which we talked about in episode 81, and the Permian period, episode 89, Pangaea formed, and by the time, the middle of the Permian period or so, Pangaea was in full swing. By this point, Antarctica had experienced its first glaciation. It had already, been through this. Not to the extent that we see it today, but there had been glaciers there, because by this point it was pretty much very close to the South Pole, very similar to where it is today. But the Permian was a good bit, at least especially toward the end of the Permian, quite a bit warmer than it is today. And so instead of getting super cold, it just got really dry. Because as we talked about in episode 89, when you have all the continents together, it makes things get very dry because on average you are farther from a coastline, and that's where the main source of rainwater comes from, oceans. So the interior of Antarctica was extremely dry during this time, despite having, by all accounts, fairly flourishing forests like everywhere else on the planet during the Carboniferous period. And when Pangaea came all together, life sort of blended across all of the continents, including Antarctica. And fossils from Antarctica that we have at this time are found in places like Africa as well. And this was actually a major supporting line of evidence for the theory of plate tectonics. It's like, well, we found these fossils in Antarctica, of all places.
Yeah, that would seem to make the case.
Yeah, and we found the same thing in Africa from the same time period. I don't think they swam there. So that was a big line of support for plate tectonics. A little bit later on, during the Mesozoic era, the time of the dinosaurs, tetrapods finally show up in Antarctica, mostly synapsids, so mammal ancestors and mammal cousins, like the famous Lystrosaurus. That was the main one that was used for that plate tectonic stuff. Lystrosaurus is very famous for doing amazing after the end Permian mass extinction, also episode 89. However, Pangaea was not to be. Most people actually kind of think little side note here, that Pangea was around for all of the time of dinosaurs, and that's not at all the case. By the time dinosaurs really got sort of in command of things, Pangea was pretty much completely broken up.
Wow.
But like I said earlier, Gondwana survived the breakup of Pangea, so Gondwana was hanging out by itself again. However, very quickly after Gondwana separated from the northern continents, Africa decided to go its own way. So Africa was the first to split off. Then next it was some of the smaller, subcontinents like India split off as well. And by around the end of the Cretaceous period, so the end of the time of dinosaurs, it was pretty much just South America, Antarctica, and Australia. And this is where most people look to Antarctica for information, because there are actually some decent and available rocks from this time, from the time period of around 70 to 50 million years ago. So right when the dinosaurs went extinct to when mammals really started getting going in the world. And Gondwana around this time, again, continuing to split up bit by bit. But the reason why this is really interesting is particularly the mammals. So what is Australia most famous for?
Kangaroos.
Right. And so kangaroos are marsupials. Marsupials being a group of animals that have, or a group of mammals that have a pouch that their babies stay in while they're babies. And that particular group of animals actually started way off here in North America during the Cretaceous. Yeah. Or the Cretaceous or late Jurassic. And then they made their way down to South America, across Antarctica to Australia.
Wow.
We don't know that, we know that must have happened, because the only places where we have significant, we have a single marsupial in North America, but we know that it came here from South America. But the only places where you have significant marsupials are South America and Australia. And we know that the only way to get from one to the other was across Antarctica. So we know that they were there, but we don't have the fossils. Sadly.
Oh, that's a shame.
Yeah. Fortunately, we do have some interesting fossils and this was new to me. We have some fossils from Antarctica of some of the weird stuff that South America was doing.
Wow.
Yeah, South America, when it split off from Antarctica, was all on its own for a long time. And when continents, just like islands, we've talked, sometimes islands have some funky evolution things going on. And South America was just a giant island for close to 50 million years. Maybe a little closer to 30. So I was looking at the wrong number. So around 30 million years, but that's still a long time.
Right.
And so some of the weirdos that were going on in South America, we also have some fossils from them in Antarctica. Things like the first penguins as well. We know of them from around New Zealand and also South America. We also have things like the xenarthrans, which are the sloth and armadillos and their relatives. They're originally from South America. We have fossils of them from Antarctica. And some of the weird hoofed animals from South America we have on Antarctica as well. So I would not be surprised if we at some point found them from Australia as well, but so far we haven't. And so drawing to a close, an icy close for Antarctica. Around 50 million years is when Australia split off.
Okay.
A little bit later, around 30 million years is when South America split. And by this point, Antarctica was all by itself. However, it was still quite livable. Around 30 million years ago, the world was quite a bit warmer than it is today.
I can imagine.
And so, even though Antarctica was still very far south, global temperatures were so much higher than today that while it was still cold and dark for about half the year, and it for sure snowed, and I'm sure in the mountains and stuff there were glaciers, but during the summer there would be even things like forests and full ecosystems like you would find, for example, in places like New York today. I'm sure there were large mammals and forests and things that were just adapted to, instead of, having 4 months of winter, to having probably, 6 to 7-ish months of cold
Mhm.
winter type temperatures.
Mhm.
However, all that changed as global temperatures cooled and Antarctica continued to move directly onto the South Pole. And at around 15 million years, Antarctica pretty much looked like it does today. Because by this point, as soon as it separated from both Australia and South America, that circumantarctic current was able to form, because now it was a much smaller landmass to be able to sort of encircle. And that really just plummeted temperatures in Antarctica. And so all this time, all those penguins have just been chilling down there, literally. And like I said, all of the animals, besides some of like the flighted birds, all of the non-flying or long-distance swimming animals are likely descendants from the ones that lived there when it was still fairly temperate.
Wow.
And that pretty much brings us to Antarctica as it is today.
Now, are we going to do a future episode on Antarctica when it doesn't exist?
Oh, it'll still exist. It's, it'll just be a lot warmer and much better paleontology.
I would call that not existing and being completely different, but, we can call it what we want.
I mean, you could say that about every area of geography that's going to change after.
Am I trying to make the case that nothing will be the same shortly from now? Yes, that's exactly what I'm trying to say.
Well, if you think about it, it'll really be living up to its name at that point, where it'll truly be the anti-Arctic. Got him.
Oh, and with that pun from Gavin, we are done with episode 91 of I Wish You Were Dead, a podcast about things that used to be alive. It is great to be back. Thank you, Gavin. Thank you, Fia. And I will see you all next week. Until then, take care, everybody.
This episode of I Wish You Were Dead was written by Fenella Campanino and hosted by Gavin Davidson, Mike Bryson, and Fenella Campanino. It was sound edited and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.